Okay, so sometimes you have to multiply both equations to get the elimination to occur. So look at our system here. You got a 2x plus 3y equals negative 16, 5x minus 10y equals 30. So you could say, well, I'll multiply the top equation by 10/3. And then that would eliminate the y's. But who wants to mess with all that fraction work? That would just be a mess. So let's not do that. Okay. So let's look for the LCD. So you're looking for it for either the coefficients on the x terms or the coefficients on the y terms. And it doesn't matter which one you pick. In fact, in this problem, for this example, I'm going to do it both ways. You'll see why in a minute. But let's say I multiply the top equation by 10 and the bottom equation by 3. Okay? So what I'm thinking is 3 and 10, they both go into 30. And I have one positive and one negative, so it should all work out for me. Now, remember when you multiply, you're going to get two new equations, a new top equation and a new bottom equation. But you have to distribute across the whole equation. You know, you could put parentheses, that might help you remember. But I'm going to get 20x plus 30y equals negative 160. Kind of some big numbers, and that happens sometimes with these types of problems. But I'll give you the good news in a minute. The bottom equation, and we're distributing here as well, we're going to get 15x minus 30y equals 90, right? Okay. And then I can add those equations. So I get 35x. These eliminate. Now make sure they eliminate. You have to have one positive and one negative. That's a really common mistake. Sometimes people have like a positive 30 and a positive 30, that's 60, not 0. So just, I'm warning you. Okay. And then on the other side, negative 160 and 90, that's negative 70. It looks like this is going to work out not too bad. And so I get x equals negative 2. Okay, keep that in mind. But remember I told you don't have to do it that way. You could have eliminated the x's. And so I'm going to choose to do it that way. So remember this. I'm going to rewrite them. 2x plus 3y. Because I might have some people watching this saying, hey, I was going to eliminate the x's. And that would work too. And then I'll tell you the advantage of doing this in a minute. Okay, so the top equation, I would multiply by negative 5. Okay, and I'll tell you why in a minute. The bottom equation, I'm going to multiply by 2. So what's going to happen is I'm going to get a negative 10y there and a positive 10y there. Now, you might be saying, well, I was going to do a positive 5 and a negative 2. Yeah, that'll work too. I just don't want to forget about the negative sign, so I just did it with the top one. But either way. Okay. The top equation now becomes negative 10x minus 15y equals 5 times 60, 80. Yeah. And then the bottom equation becomes 10x minus 20y equals 60. Okay. Those eliminate. That's good. You're going to get a negative 35y. And here you're going to get what? 140? So if you divide by negative 35, you're going to get y equals negative 4. Okay. So you have found the ordered pair by doing it that way. Notice that you got what y equals here, and we already had what x equals, so you don't have to do any substituting. And that way, if you made a mistake on the first part, you at least got the second part right. Okay, so we're going to say the answer is negative 2, negative 4. But just in case you're like, no, I don't want to do it that way. I would have rather substituted the negative 2 in. Like, why don't we just plug that in, you know, to an equation? And it doesn't matter which equation. I'll do the top equation. 2x plus 3y equals negative 16. Now you have 4 equations. This one, this one, this one, and this one. You could plug it into any of them. I try to pick the one with the smallest numbers. Okay, so 2 times negative 2 plus 3y equals negative 16. Negative 4 plus 3y equals negative 16. If I add 4, this better come out to be the same thing we got for y already, right? 3y equals negative 12. Divide by 3. Yep. Y equals negative 4, which we already said, but just you could do the substituting to find y instead of going through the whole elimination process again. Okay, so we got an answer. There it is. Yay.